Okay, this week we are focusing on multiplying multi-digit whole numbers. And so I'm going to take you through a quick few steps to help you review this week before the test. So one thing you need to know is if we are multiplying, we first want to be able to estimate so that we can compare our estimate to our product to see whether or not we are actually reasonable. So 63 times 8, I know is 63 is about 60 and 28 is about 30. So I know that this is going to be 1,800. And so as I solve, I'm going to go ahead and make sure that my answer is really close to this and nothing really far off. So in 5th grade, we use 3 strategies. We look at the break apart and distribute. We look at the area model, and we look at standard algorithm. And standard algorithm is the one that we really want them to know for this particular standard, and we push them to get. So that's our end goal. That's with the goal in mind. So for break apart and distribute, I'm going to look at this as that 63 as 60 plus 3 times, and then I'm going to take the 28 and break it apart as well. 20 plus 8. From here, I'm going to go ahead and distribute it. So I'm multiplying this 60 times the 20 and this 60 times the 8. So I rewrite this as 60 times 20 plus 60 times 8. Then I'll go ahead and do the same thing with that 3. So 3 times 20 plus the 3 times 8. Okay, so here I have my partial products are going to be 1,200, 480, 60, and 24. And when I add this all together, I get an answer of 1,764. Now that product is reasonable because it is in fact close to our estimate of 1,800. So that's the break apart and distribute method. Now this is not a method that we use a whole lot in 5th grade, but it is one that students should be familiar with, as they could possibly see it on a test as one way in which to solve a long multiplication problem. Okay? All right, so another one that we use quite frequently is the area model and the standard algorithm. Standard algorithm goes hand in hand with area model. And I like to tell students that the longer number always goes on top. It's not necessarily going to be the bigger number. Okay, so here's my standard algorithm. And I'm going to draw this area model. With our area model, whatever number or digit on top here should also be on top of our area model. So I'm going to do 60 plus 3 here, and then 20 plus 8 here. Now, I like to tell students to go ahead and actually write the expression within the boxes. So this would be 60 times 8, which would be 480. This would be 8 times 3, which would be equal to 24. This would be 60 times 20, which is equal to 1,200. And this would be 20 times 3, which is in fact equal to 60. Now from here, I have the students add going across. So 480 plus 24 is going to be 504. And 1,200 plus 60 is going to be 1,260. And after adding them together, we should see that the final product is 1,764. Now, the area model directly correlates to the standard algorithm. We always start in the ones place, and I tell students to draw arrows. We're doing 8 times 3, and then we're doing 8 times 6. So 8 times 3 is 24. And 8 times 6 is 48. Plus that 2 would be 50. And if you notice, there's a direct correlation. And that is only because the number that we used on the top here matches the number that we used on top here. So we're done with the 8. Yay! Now, when we move to the tens place, we have to think of this as 2 tens. So that's why we add that 0 in. Now, we want to go ahead and multiply again, but we go from right to left. So 2 times 3 and then 2 times 6. So 2 times 3 is 6, and then 2 times 6 is, in fact, 12. And that, again, matches. And we go ahead and add those up. We have 4, 6, 7, and 1. And again, we're trying to get students to move into the area model. Not the area model, sorry, the standard algorithm. So really want to push standard algorithm as much as possible this year. Using the area model is perfectly fine. If you can relate it to the standard algorithm, if you can actually look at both and see how in fact they are related. So I want to go ahead and show you some common mistakes that are made by students. Let's say we have the number 427 times 53. Students are going to want to do same thing. We talk about right to left. So 3 times 7, 21. 3 times 2 is 6, plus 2 is 8. 3 times 4 is, in fact, 12. The two biggest mistakes that students make is they will forget to add a 0 right here in the ones place because it is, in fact, 5 tens and not 5 ones. I tell my students to go ahead and cross off this number 2 so that they don't get confused later on. Now, when multiplying 5 times 7 to get 35, often students are going to want to take that and put it over 4 and not over the 2 because they're so used to moving to the next column. And so that's the second big mistake that students make. Here we have 5 times 2 is 10, plus 3 is 13. Thing 3, carry it to that next column. 5 times 4 is 20, plus 1, 21. And we add 1, 3. All right. Now, students should constantly checking their work. They should be making sure that they have their zeros in the correct location. They should be ensuring that their multiplication is correct, went in order from right to left, and they are doing all the steps that they need in order to solve the problem correctly. So students should be solving it and almost solving it again. My students are often told to use grid paper to solve long multiplication problems because when using grid paper, it keeps your digits in line rather than just floating all over your paper. So the magic word for this video is going to be grid paper. All right, thanks for watching.